So let's get to it. Chapter 6 is all about preparing your brain really for what's coming in fractions. Understanding that numbers fall into one of two categories, prime and composite. And to help me with that demonstration today, I've been talking about this metaphor for a long time. And in normal times, we would be dumping out buckets of Lego and building composite numbers with agreed upon Legos that represent prime numbers. For instance, now you might have a little bit better of an understanding than my 5th graders did today because you're older and more experienced with this topic. But here's what I need you to grab onto for a second. Everyone listening? Because I can't leave my desk here so I can show you what I'm doing. I'm going to establish each of these colors to represent a different prime number. Okay? So all of the yellow Legos are going to be the prime number 2. Okay? And just by themselves, they're worth 2. But when I click a 2 and a 2 together, what composite number does that make? 4, right? Because 2 times 2 is 4. Well, what would 2 times 2 times 2 be? 8, right? And this is another way to say 2 to the 3rd power. Can we all understand that connection right there? 2 to the 3rd power. So all of the yellow Legos are going to be worth a prime factor of 2. All of the red Legos are going to be worth a prime factor of 3. All of the green Legos are going to be a prime factor of 5. And all of the blue Legos are going to be prime factors of 7. And then I brought a couple of odds and ends, like these burgundy pieces and these lime green ones, to represent other bigger prime numbers that aren't as common, but they're prime numbers like 11, 13, 17. So I've got some other spares that we can use to represent those amounts. So far, are you understanding my metaphor here? This is not about addition. What is this about? Multiplication. Can you see that a little better there? Good. So if I was building a composite number, pay attention to my primes. Here's 2s, here's 3s, here's 5s, here's 7s. What composite number would this be? 2 times 2 times 3. What would this number be? 2 times 2 times 3. What would this composite number be, class? 12. Very good. And if I put another 2 on it, what would it be? 24, right? Okay, good. How about this one? What would 5 squared be? 5 times 5. What would 5 squared be? 25. Feel free to unmute at home and say what you're thinking out loud. That's a good way to show your understanding to both me and your classmates. All right, so how about my 7s? What if I had a 7 and a 2 and I popped them together? What composite number would
14.
this? 14. Good job. Now, I want you to imagine a factor tree and decompose a number for me. Tell me what Legos would I need to make the number, let's say 36 to start. All right, knowing that these are 2s, these are 3s, these are 5s, these are 7s. What would I need to make 36? So I'm thinking like initially I might break 36 down into, let's say 6 times 6, right? So I'd have to build a 6 times 6. And together it would make what? 36. But does it really matter if I do 6 times 6 or maybe 4 times 9, right? Or maybe 18 times 2? It doesn't matter because once you snap together those primes, what happens? You have the same value. You have the same number. So this is what I was trying to talk to you about when we were doing greatest common factor, because when you look at 2 numbers, here I'm going to build 2 numbers, and you compare them to each other, you're trying to, in numeric form, like in number form, recognize what do they have in common, right? What do these two number stacks that I've made, what do they have in common? They have a yellow and a red in common, one yellow and one red, which in number form, what would that be? One yellow and one red. What would one yellow and one red be? A 2 and a 3 is a 6, right? So these two have, now I can rearrange their ordering because their multiplication is commutative, right? So I don't have to worry about which one was on the top and bottom. But if they both share the same factor, then I can simplify or pull out those groupings to see what the true value of the relationship is left behind. So when you simplify a fraction like 12 over 24, what you're doing is saying, I see what they have in common, and you're getting rid of it, but in number form. Does that make sense? What do you think about that? Is this a creepy, crazy metaphor, or is it matching your understanding a little bit? What do you think? On a scale of 1 to 5, 5 being it makes total sense, 1 is you're crazy, Mrs. Moore. Where do you land right now, roughly?
4.
Okay.
3.
All right. Thank you. Thanks, Paige. Let's build another number. Now, normally I would dump these out on your desk and you actually building them. Do you think that's more meaningful than me building them in front of you? Yes. So your homework tonight is when we're done with page 100, what do you think I want you to do?
Go home and build some Legos.
Build some, not Legos, build some composite numbers, right?
Legos.
Build some composite numbers, decompose them into what you're calling certain prime values, and practice identifying, like, between two composite numbers, like, what do they have in common? And relate that idea to what simplifying means. All right? So here, I'm going to build you a number, and then you're going to tell me what that is.
Okay.
All right? So in case you can't see that because of the light, you've got 2 yellows, 2 greens. What standard form value can you give this number stack? Type it in, say it out loud. Tell me out loud, what is this? I can't hear you. 100. Okay, or we could rearrange it like this if it, because multiplication is commutative. So I can rearrange their ordering. Okay, what would, this looks like 10 times 10, right? Does that make it easier to see?
Yes.
What's 10 times 10? 100. So this is 100, right? Tell me what this number is. This number.
What are the reds again?
3, 2, 3, 5, and 7. So what's the red one? What is this stack worth?
75.
75. Well done. So what do these two stacks of 175, what do they have in common? What do they have in common? 2 greens, which is worth what? What do we know? It's worth 25, right? Hey, what's the GCF of 175? What's the greatest common factor? What's the greatest common factor? So what does greatest mean? Biggest shared factor, right? What's their biggest shared factor? 25, right? So when we did distributive property, this is what we did. We said, okay, they share a 25. If I take a 25 from this stack, collect it, and this stack, collect it, right? These were the parts in parentheses, and this was the factor out in the front. Can you see it in shape form now that we did it in number form last week with distributive property? And if we wanted to pass it back out, we would give 25 to this stack and 25 to this stack, and you'd have your two numbers again. So we can practice the skill of not only GCF, but distributive property, prime factorization. You can do this with Legos. Isn't that crazy? All right, I'm going to build a more intricate number. Are you ready? And then we're going to get on to least common multiple. How is that related? I'm going to just start stacking up some stuff here. And all right, I'll put a big old 7 on top. So see if you can calculate that value.
How much are the yellows?
2s. So we've got 2 2s, 2 3s, and 1 7. So the prime factorization here would be 2 to the second power times 3 to the second power times 7. And I'm seeing my chat box blow up here a little bit. What do we think the total answer of this would be? What are we getting so far? Maybe it would be more helpful to sort them into like categories. Okay, so there's 9. 9 times 4, that's 36. 36 times 7. Anyone have an answer? Go ahead.
252.
Nice. All right, 252. And look at all those chats coming in now. Nice. Well done. All right, one more. And I'm going to get the infamous 11 piece out. Everyone say, ooh. Here's the 11 piece. 11. And one more. All right. So we've got a 2, a 3, a 5, and an 11. That's the prime factors. 2, 3, 5, and 11. What number, what composite number does this make? Calculating. You got it already? What was it? 330. And you can see it a little bit easier by going, hey, this is a 10. 10 times 33, 330. Did you see it that way? Okay, he did 11 times 2, which is 22. And then 5 times 3, 15. And then you did that part? Oh, and then he did this. And then he did this. So it sort of shows the difference in how we do a factor tree, right? Some people break it down this way, some people break it down that way, but in the end, what do we all have? The same what? What are these called? The same what? Prime factors, right? We have the same prime factors in the end. All right, I expect a round of applause for that demonstration. Thank you, thank you. Oh, that was trademark. Don't you go putting it on YouTube. I thought of that myself and I will come after you for if you try taking my idea. All right. I'm gonna pull up our slide now. And so going back to the connection here, boys and girls. Shh. This is 320. But you could break it in any of those ways, right? You could start by doing 2 times 160. You could start by saying 4 times 80. You could start, oh, I don't have all the right ones in here. This one's supposed to be a green, sorry. You could start by saying 5 times 64, right? You could start in any fashion you want, but what are you gonna get when you're all done? How many yellows are there gonna be? 6 yellows and 1 green, right? When you're all set and done. So when we are talking about greatest common factor, you're comparing what they have in common with each other, right? And we did that last week when we worked on distributive property. Hey, would you guys mind shutting the door so I'm not disturbing you? Thank you. And then today we're going to work on something called least common multiple, which is very closely related. So least common multiple is involved with the leftover factors that those numbers share. So the greatest common factor is the ones that they do share, but combined with the other factors, that creates the least common multiple. So I'm not sure if you have this definition yet in your notebook, but I think we took a day when we wrote prime factors, composite factor. Did you write that in your notebook? Want to check? Check what you have in your notebook. Do you have chapter 6 vocab, something like that, where it says prime numbers? What's a prime number? What's a composite number? Anything like that? Okay.
Are we allowed to use a notebook for the quiz?
Yeah, I don't think there's anything in it that you're gonna need besides a multiplication chart and maybe prime numbers. And I'm gonna give that to you. So you won't need your notebook for the quiz. But least common multiple is calculated by combining all of the prime factors that exist between the two numbers. But you only count the shared factors once. And we can go through streams of multiples to practice this skill. And that just takes longer. I want to teach you how to find least common multiple using an understanding of what prime numbers are. Could you find least common multiple between two numbers by writing out all their multiples until you find one they have in common? Yeah, you could do that. But do you think you're more likely to make a mistake when you get past a certain point in the multiples, right? So this method of using prime factor team instead of listing multiples is going to get you a more accurate and reliable answer. All right, so look at this image I found. This is an image of all the multiples intersecting each other. I just thought it was kind of interesting. So what multiple, what's the least common multiple that 2 and 7 share? Do you see the overlap of 2 and 7? 14 right there. What's the least common multiple between 2 and 5? Do you see that area right here? 2 and 5. Do you see it shaded in right here? 10. Isn't that cool? And what's the least common multiple between 2, 3, 4, 5, and 7? 420 is the least common multiple. And honestly, I don't think you want to write out multiples 2, 4, 6, 8, all the way to 420, but you could have easily found their least common multiple by breaking it down into prime numbers, multiplying those numbers together, eliminate any duplicates. All right, let's do some least common multiples. All right, I'm going to show you method 1 is listing, which is easy for low numbers. I'm going to do this off to the side. So method 1 is listing method. This is on page 99 of your workbook. So if you guys want to pop that open right now. Listing method would be going 4, 8, 12, 16, 20, 24, 28, 32, 36. And you're hoping that you're going to find one, right? But it's really going to depend on what's coming in the next set, right? 5, 10, 15, 20, 25. Did we come across anything they have in common yet?
Yes.
Yes, we did, right? What number do they share? What number do they have in common? 20 is the smallest. It's the least shared multiple between those two numbers. So that's listing method. And that works for smaller numbers. It works. But what I'm encouraging you to do is to understand it in a different way. Understand it by comparing the primes to each other, okay? So here's 4 and here's 5, right? Do they have anything in common with each other? Nope. So just click them together. What's 2 times 2 times 5? 20. What's the least common multiple? 20. All right, so start to understand how prime factors really make this work, and it won't be like learning two different skill sets. I feel like sometimes when you first hear about greatest common factor, least common multiple, you're like, what do these things even mean? What are they for? But if you can understand that they're both just different ways of utilizing prime numbers, then you might have more success when we get to fractions. All right, between 5 and 10. We're going to do it both ways, listing method and then prime number method. So 5, 10, 15, 20, 25. You can see where we're going, right? 10, 20, 30, 40, dot, dot, dot. It's easy to see with small numbers, right? That what is the least common multiple they have? 10, right? Now let me show you Lego style. What do these two have in common? A 5, right? So I'm going to get rid of one of the duplicates. So what is their least common multiple? 10. And that's the answer that we revealed with listing method. So if you're more comfortable doing listing method here with the smaller numbers, go for it. I'm telling you that as we get bigger numbers, bigger quantities, like look at number 7. Number 7 has more factors involved, right? How about between number 3, 7 and 2? 7 and 2, what would the least common multiple between 7 and 2 be? I have Santo telling me 14. What do we think about 14, everyone? All right, and if we did it listing method, we would be saying in our mind 7, 14, 21, right? And along the same line, 2, 4, 6, 8, until we got to a spot where they intersect at 14. If you wanted to look at it according to Lego blocks, they don't have anything in common. So connect them together. What's 2 times 7? 14. Okay. So start to use that metaphor to help you out. How about between 11 and 5? Now, here's my 11 piece. Do 11 and 5 have anything in common with them? Nope. So then their least common multiple has to be their two prime factors multiplied together. What's the least common multiple of 11 and 55? 11 and 5, everybody. It's 55. Do 4, 5, or 10 share anything in common with each other? They do, right? Let's see. Between 4, 8, 12, 16, 20, 24. I'm thinking it might be 20, but let's take a look here. So 20 is the least shared multiple they have, right? In Lego land over here, Legoland. It's hard to show it on the screen there. I'm not sure if you guys can see it. In Legoland, we've got, here's 4, here's 5, and here's 10, right? What do they have in common with each other? They don't have anything truly in common with all of them, right? This one's a tough one to imagine with least common multiple. This one is for number, what number is this? Number 4? Are we working on 20? Envisioning 20?
Like 21.
No, in your math workbook. What number is this?
Yeah, 20.
Number 5. Sorry, number 5. So we ended up getting 2 2s and a 5 is what they did not share in common with each other. Okay. What would the least common multiple of 5, 6, and 12 be? Can you start running those multiple streams in your mind and then relating that prime factor approach? What would the least common multiple between 5s and 6s and 12s be? Use your multiplication charts to help, okay? Zoe, are you okay back there? Okay, maybe sit up. So do you have a multiplication chart too, guys? 5s and 6s and 12s. Where's the first place they're going to intersect each other? I've got an answer for 60. Anyone think they meet before that? 60? What do you think? 20? I know 5 goes to 20, but 6s and 12s don't go to 20. So 60 over here for this answer. Right. What about 21s and 70s? 21s and 70s. So 21 looks like this, right? And 70 looks like this. And what do they have in common? A blue, right? So we're going to get rid of the extra blue to find their least common multiple, which would be this composite number. What's their least common multiple, guys? Anyone know what this number represents? 2 times 3 times 5 times 7. Maybe this will make it easier. 10 times, what's this guy over here? 3 times 7, 21. So what's the answer? 210? I got 210. Santo, you got 210? Here's how you can prove it. So I'm doing prime factors here on this with the Legos. What do they share with each other? And I'll just put a 10 here. I know 10 continues to break up, right? But what do they share? They share a 7, right? So if I want the least common multiple, I don't want it to repeat on the 7s. I'm only going to go on with one copy of 7. So that's why I removed my extra 7 from the pot. And they still share a 10 and a 3. So together with that extra factor of 7, I get 210. All right, what about number 8? Between 5 and 7 and 10, what do they share? Katerina, you got it? 70. I can't hear you, honey. 70. 70, I'm hearing. 70. 70. What do 2, 4, and 5 share, boys and girls? 20? Good job. All right, so for your homework tonight, you're going to be working on not only page 100, but if you can build some composite numbers for me, just to play around with this idea of decomposing a number into primes. You're going to just need 4 colors of Legos to do the basic numbers. But if you want to try something that maybe has an 11 in it, or maybe a 13, then you'll need some other colors. Or maybe a different shaped Lego. Maybe use one of those unusual shaped Legos to help you out in that department. I just thought both color and shape would really help us with the concept today. I'll give you a minute to start working on 100. We've got about 5 minutes left of class.
I thought you said there was no freckles.
There is no what?
Freckle.
There is no freckle. Well, let's change that right now. That must have been a, thank you, Colin. That was something I decided to do clearly after I had already made this Google slide. Here, want me to put it in all capital letters?
Yeah. That's not all cap.
There we go. How's that, everyone? Is it clear now? You have no freckle? But instead, what do I want you to do?
Make it like stop. Use Legos. Well, I have so many like font size 50. I do like 84. Are we doing red about it? We like size 50. Yeah. No, I just need to make it.
How's that? Is that better than doing freckle this week? Play around with some Legos, build some composite numbers, practice this idea of shared common factors related to GCF, LCM, prime factorization, distributive property. You'll be all set for your quiz coming later this week on Thursday, all right? I will see you guys again tomorrow for another Zoom. And I hope you have a great rest of your day.